Problem 1. The graph of the function f of x equals absolute value of x cubed over x cubed minus 8 has the following asymptotes. When I look at the problem, I notice that they're talking a lot about vertical and horizontal. And I know that vertical asymptotes will just occur where there's a non-removable discontinuity. And I know horizontal asymptotes are going to occur when I'm finding the limit as x approaches infinity. So what I'm going to be looking for, since this is a calculator section problem, I am going to graph it, and then I am just going to be looking for the asymptotes. So if I graph it, when you do graph it, be very careful that you put the denominator in parentheses, and when you graph it, you should get something, there should be an asymptote happening at 2, and then the graph looks something like this, and then it looks something, just something kind of like that. Okay, so if I'm looking as x approaches infinity, I could draw a horizontal asymptote that's going this way, and then the limit as x approaches negative infinity, I could actually draw a horizontal asymptote that looks like that. Okay, so if I'm looking at my graph, there is one vertical asymptote and there are two horizontal asymptotes. So my answer would be choice C. Okay, 2. A farmer needs to fence in a rectangular region shown. Since one side is along a river, fencing is needed only for 3 sides. What should the ratio of x to y be to maximize the area of the enclosed region for the given total length of the fence? All right, first thing that I'm going to do in this drawing, I'm going to put another y there because I will need another y. This looks like a related rates problem to me. The biggest thing is, it's not a related rates, excuse me, it's a maximum problem. I would like to maximize the area. So I know that I need a formula for area, and then I'm going to take the derivative of the area. So those are the two things that I need to do. Okay, the area of this region, since it's a rectangle, is just length times width, and in this case, it will be x times y. So I do have a formula. I would like to take the derivative of it, and I'll actually, when I'm done, take the derivative and set it equal to 0. I notice that I have 2 variables, and I would really just like to have 1 variable, so I'm going to come over here and do a little side trip. Okay, usually this one says for the given total length of fence. Usually they tell you a number. They don't tell you the number this time. So I'm just going to call it F. So if I'm looking for how much fence, the fencing is going to have to be, I'm going to need 2 y's and 1 x. So 2 y's plus 1 x. And I would like to solve this for either x or y, and it looks like it's going to be easiest to solve it for x. So I'm going to have x equals F minus 2y. And I'm not going to worry too much about that f being there. It's just, it could be 100 or 200 or 500. I'm not sure, but it did say that it would be given to me. So now I'm going to come over here, and I know that x is equal to f minus 2y. And now I'm going to distribute. So I'm going to get fy minus 2y squared. And then once I get my formula, I'm going to take the derivative. The derivative of fy will just be f, because f is just a constant like 100 or 200 or something like that. And then it will be minus 4y. And I know that to find a maximum, I'll take the derivative and set it equal to 0. So if I take that and set it equal to 0, I'll get negative 4y equals negative f. So if I divide both sides by negative 4, I'll get y equals f over 4. And not that it helps me too much, but what I'm going to do now, because I want to find a ratio of x to y, I'm going to come back over here and put that in for y so that I have an x value. So x will equal f minus 2 times f over 4. That will equal f minus f over 2. And if I get a common denominator here, x will equal f over 2. So now from here, I just need to figure out what is going on. So I've got x, the dimensions of x are f over 2, and the dimensions of y are f over 4. So I just tried to do an example like with fencing just to see if I could try to figure out what's going on with the ratios. So I said, okay, what if we had 100 feet of fencing? Is it feet? I don't know. What's 100 feet or whatever of fencing. If I have 100, x would be 50. And my y would be 25. So if I'm looking at the ratio to compare those two, I would, yeah, I did it right. When I'm looking at that, I notice that the x is 2 times bigger than the y. So I'm going to choose choice D because there are 2 x's to every 1 y. And then I believe I am done. Okay, question 3. The maximum value for the function y equals x cubed plus x squared for x is less than 0 is approximately what? Okay, if I'm looking for a maximum value, number 1, that is going to be a y answer. And then the second thing is if I'm looking for a maximum value, I know that I usually do a y prime chart. And usually when we're doing maximums, especially if it's absolute, we need endpoints, but they didn't give me endpoints, so I guess I don't care about it. All right, so I'm going to take the derivative. The derivative would be 3x squared plus 2x. And then I'm going to take the derivative and set it equal to 0. So I'll factor out an x, I'll get 3x plus 2. And so my 2 answers would be 0 and negative 2/3. And since I just want all the x's less than 0, I'm not going to consider that as a critical point. So if I put, well, this is y prime. If I put negative 2/3 in there, if I pick something over to the left of negative 2/3, let's say negative 1, if I plug negative 1 into the derivative, I will get a positive value. And if I pick something over here, let's say I can't pick 0 because 0 is a critical number. Let's say I picked negative 1/3. If I put negative 1/3 into the derivative, I'll get a negative answer. So I'm looking for a maximum value. I notice that when x equals negative 2/3, this is a maximum because the derivative goes from positive to negative, but it's not asking me for the x value, it's asking me for the y value. So I'm going to take x equals negative 2/3 and I'm going to plug it in to the original equation. So I'm going to have y equals negative 2/3 cubed plus negative 2/3 squared. And since this is a calculator problem, we can go ahead and just use our calculator to get that. And when I did that, I got 0.148. So 0.148 would be my maximum value. Okay, problem 4. Which of the following quantities would not be represented by the definite integral 0 to 870 dt? So let me just look at each one. I'm actually going to, I know A is my answer, I'm just going to go down and say why B would work. If I have 70 gallons per hour for 8 hours, if I'm taking the integral of that, the per hour cancels out, so I'm just left with 70 gallons. Part C, the per hour drops out, I'd be left with 70. On this next one, per hour drops out, I'd be left with 70 again. And this next one, 8 minutes, 70 minutes, millimeters per minute, I'd be left with a 70. So I'm all set. Now you're probably wondering, why didn't she pick A? All right, this one, notice it was per hour for 8 hours. This one was per hour for 8 hours. This one is per hour for 8 hours. This one was per minute for 8 minutes. Notice that all of the units cancel, or they work together. This one is miles per hour for 8 minutes. The units do not match. So since the units do not match, that would be why I would pick choice A over all of the others. Okay, number 5. If the average value of the function on the interval is 10, then what would the integral from A to B? So I'm going to, since I see the average value, I'm actually going to write the formula for average value, which is 1 over b minus a times the integral from a to b of f of x. And they told me that that average is going to equal 10. Okay, and then basically, if you look at it, they are asking me for what this part of my problem would be. So there, I would like to solve for that. So since I have 1 over b minus a, to get rid of that, I'm going to multiply by the reciprocal of that. And so when I do that, those two cancel out. I'm just left with a over b f of x, and then that will equal, if I distribute that, it will be 10b minus 10a. So that's what the integral would have to equal, and that is choice C.